Welcome to Homework Lib.
Okay, so here there are coefficients of linear expansion, and the coefficient at which the index of refraction changes are given. The index of refraction of rod, let me write this as it as Ng, is given, that is 1.48. Right now, at 20 degrees, the length of rod, let me write this as y naught. The initial length is 3 centimeters, so this is equal to 0.03 meters. Right. Okay, and a Michelson interferometer is used, and the rod is being heated so as its temperature increases. Okay, so the rate of increased temperature is 5 degrees Celsius per minute, and the source of light has a wavelength of 589 nanometers, and which is equal to 589 into 10 to the power minus 10 meters, right? Sorry, minus 9 meters. So, okay. So how many fringes cross the field of view each minute? So we were used to crossing the fringes by actually moving the mirror, right? But now the movement of mirror or the movement of glass rod, as in this question, is due to heating, right? So here, by two different ways, there is the changes in fringes by two different ways, and one is due to expansion of rod, right? So it replaces some amount of air, so one is due to expansion of rod. And the change in fringes, we know from the formula in the book, the changes in fringes m equals to 2 times the moment of mirror 2y times lambda, right? So in this case, the change in mirror in the fringes, number of fringes, is equal to 2 times due to the expansion of the rod, so del y, right, upon lambda g. And lambda g is what? Lambda upon eta g, or ng, where I have used this relation here, lambda g equal to lambda upon ng, where lambda g is the wavelength of light inside the glass. Now minus 2 times del y, and now in air upon lambda, right? Now what is the change in length? Del y. So let me keep that common here. 2 times Ng minus Na, and del y. What is del y? Del y is the initial length times alpha times change in temperature del theta. And it is given that del theta, the change in temperature, is 5 degrees centigrade per minute. Right? So let me write here 5 degrees centigrade. We are all solving in period of 1 minute. So this upon alpha. Now you know the value of Ng, you know the value of Na. Let me write here, refractive index of air equals to 1. We know y naught equal to 0.03. We know alpha. Alpha is given in the question, that is equal to 5 into 10 to the power minus 6 per degree Celsius, right? And we know del theta, we know lambda. Just plug in all the values in here. So this gives me del m equals to 1.22. Okay, and the second reason for the fringes, for the movement of fringes, is due to the, the change in refractive index of rod, due to change in refractive index of rod, right? And this is due to del m equals to 2 times the change in refractive index, right, into y naught. the initial length upon lambda naught. You have to note that since the effect is very small, we can consider these two separately and not at the same time. Okay, so this is equal to 2 into, now the change in the refractive index of rod is given, the coefficient is 2.5 into 10 to the power minus 5 per degree Celsius. So since the change is 5, so this should be 5 into 2.5 into 10 to the power minus 5, right? Because this is per degree Celsius and this is the degree Celsius that is changed. Now into y naught is again 0.03. And what is lambda? 5.89 into 10 to the power minus 7. So this gives me del m equals to 12.73. So in total, the total changes in fringe m equals to 12.73 plus 1.22, nearly equal to 14 fringes. So these many fringes cross the field of view, and hence this is the solution to this problem. Thank